Hello and welcome everyone to my brain, my house. This is Physiology Capsules. Today we're going to talk about osmosis. Before we start, I want to review the membrane transport mechanism, which differentiate into passive transport and active transport according to the energy used. Passive transport, spontaneous, no energy required. From high concentration to low concentrations, we have simple diffusion, facilitated diffusion, filtration, osmosis, and we have the active transport. Its energy needed transport against concentration gradient from low concentration to high concentration. We have active vesicular transport, active carrier transport. We talked about these two in the previous videos. Today's lecture is osmosis. Osmosis is the net diffusion of water from a region of high water concentration to a region of low water concentration, or from a region of low solute concentration to a region of high solute concentration through semi-permeable membrane. This is a passive transport, which means spontaneous, no energy needed, need channel to move quickly. This channel called aqua ore. Aqua mean water, pores mean vapors. Can move without channel, but it's slowly. Why we say that it needs channel? Because as we remember, when we talk about the cell membrane, this is the cell membrane, okay? This is the cell. The cell membrane, as we talked about, we have phosphate head and we have two tail, right? This phosphate head is hydrophilic, so it loves water, but this hydrophilic, so the water cannot pass easily through this membrane. It needs channel called aqua pore. As we see here, we have the semi-permeable membrane. It is very important. If we said we have, as we see here, this is the molecule, sorry, sugar molecule, and this is water. We have here high solute concentration here, low solute concentration here. So the water will move through from region of high water concentration to a region of low water concentration, or from region of high solute concentration to a region of from region to low concentration to high concentration. As we say here, water molecules, water is moved here. Osmosis occur. Okay. Any solution have or has solvent and solute. Solvent is water, solute like sugar molecule, or so on. In order to this osmosis to happen, there should be a difference in concentration in solutes. This will make them osmotically active particle, okay, that will make water to diffuse them. So osmosis is a long concentration gradient of water, but against concentration gradient of solutes. This is a very important point to focus on. As we say again, or see again this picture, from a region of low solute concentration to a region of high solute concentration. The aim of this osmosis is to reach the concentration equilibrium between the two solutions. Okay, as we see here, low solute concentration, high solute concentration, osmosis happens through semi-permeable membrane, so until it reaches the equilibrium between the two types of solutions. Okay, concentrated solution versus diluted solution. Concentrated means we have more solutes and less water, but dilute means we have less solutes and more water. So the direction of the water diffusion is from diluted solution to concentrated solution. This is diluted solution. Water will move from here to here. Concentrated solution. Why is that? Because we have more solutes here. Okay, from low solute concentration to high solute concentration. The next topic we talk about the osmotic pressure. This osmotic pressure is needed to stop osmosis, and it's created by solutes. That's why we call it osmotically active particles, and it depends only on the particles of the solutes rather than the solutions. Okay, these solutes, when osmosis happens, water will flow until reaching the equilibrium. Then these solutes will create osmotic pressure. This osmotic pressure will stop the osmosis to happen, further osmosis to occur, or further osmosis to happen. We have different equations and calculation to calculate this osmotic pressure. I think it's called a Van Hoff solution. Okay, this picture is very amazing picture. As you see here, this is solvent solution. Osmosis happens from here to here. Sorry, from here to here, and osmotic pressure occurs. The last topic talk about osmolarity and osmolality. Okay. Osmolarity is the number of osmoles of a solute in liter of solvent, while osmolality the number of osmoles of solutes in kilogram of solvent, milliosmol per kilogram, milliosmol per liter, osmolarity liter. To not forget about these two things. Which one is more accurate? Osmolarity. Why? Because weight doesn't change. Okay. The weight doesn't affect by the temperature or the volume. Unlike in the opposite, we have the solution which affect the osmolality, while in the osmolarity, not osmolality. The heat solution, it will expand and increase the volume. Changed mean. This is osmolarity, not osmolality. Sorry for this mistake. The second one, which one is more practical? Osmolarity. Because if you ask to give patient a normal saline, you're going to give him, for example, 500 cc or milli, not 500 gram or kilogram of normal saline. Doesn't make any sense. Okay, that's it. I hope you enjoyed this lecture. Don't forget to like this video, give a comment below, and subscribe for more video. See you for the next time.